Okay, we're looking at review exercise 5, or sorry, mixed exercise 5, I should say, from this first year core textbook. So that's on straight line graphs. We're on question 10. So we've got an exam question, so we can see how many marks it's worth. So 6 marks, quite a decent amount of marks for just a single question. And it's also problem solving. So I suspect there's going to be some sketching and thinking carefully about our method involved. Okay, so we've got line 1, and we're given 2 coordinates that line 1 goes to. So if we need to, we can get the equation of line 1. I suspect we will. We've got the equation of line 2, and we're told that the y-intercept of line 2 is coordinate C, and then we need the area of triangle ACD. Okie dokie, right. Okay, so well, what do I know? Well, I know C, because I can easily get the y-intercept of that. I know A. So it's coordinate D I need, and that's where they intersect. So as suspected, before I sketch this out, let's get the coordinates of D. So let's find line 1. So first thing I'm going to do is get the gradient. So gradient change in y over change in x. So I'm going to do this coordinate, take away this coordinate. So my change in y is 7 minus -2. And my change in x is 6 minus 0. So that's 9 over 6, or 3 over 2. Then I'm going to use y minus y1 is m times x minus x1. So there's my gradient. And my x-coordinate, I'm going to use the 6, 7. I'm sorry, not my x-coordinate, my coordinates. I'm going to use coordinate B. I could use either. I mean, that one's a bit, actually, do you know what? I'm going to change that because that's got a 0. I was thinking about not using the negative, but I think because it's got a 0, that one would be easier. But you can use either. So I'm going to use the coordinate 0 minus 2. So there is my y-coordinate, and there is what I'm going to use for x1. So it's y minus -2 is my gradient times x minus 0. So that's going to become y plus 2. And then if I multiply those brackets out, I've just got 3 over 2x. And that's not my final answer. So I'm not even going to worry at this stage about rewriting that in any particular form. Because what I want that for is to find where it intersects line 2. So before I worry about rearranging, I'm going to think about the best way to solve that. So I think all I'll do, so I think I will rearrange this one. So I'll rearrange this one to make y the subject. So that will just become y is 3 over 2x minus 2. And then, so that's line 1. Line 2, I'll just copy from the question. So x plus y is 8. And then I think all I'll do is substitute that in for y. So x, oops, you could see it. So x plus 3 over 2x minus 2, that's just substituting in for y, equals 8. So 1x plus 3 over 2x is 5 over 2x. Let's add the 2 over, multiply up by 2, and divide by 5, and I get x is 4. And I suspect I will need the y-coordinate as well. So I think actually that just looking back through these equations, that's probably the easiest one to look at. So if x is 4 and x plus y is 8, then you can't actually see what I'm writing there. Y is 4 as well. Yeah, so all I'm doing there, let's move this up for a second. So all I've done there is look to that equation and just said, well, if x is 4, y is 4. Okay, so that's the coordinates D. So D is 4, 4. A was given to me in the question, so A was 0 minus 2. And C was where this cuts the y-axis. So something, let's use a slightly different colour. Okay, so where this equation cuts the y-axis, well, something cuts the y-axis when x is 0. So when x is 0, y is 4, so it's cutting the y-axis at 0, 4. No. So yeah, so what on earth am I talking about? Okay, let's try that again. So everything was fine up to that point. Right, so when x is 0, y is 8. Yeah, 4 in the brain. Okay, so that's going to be 0, 8. That makes more sense, yeah, because I mean, you could have actually avoided all that and just rearranged that to y equals minus x plus 8 and seen the y-intercept was 8 from that. Okay, so anyway, after that faffing around, we've got what we want. Okay, so I'm going to hope that somehow I can get a right angle triangle here, because obviously that will make it quite easy to then do half base times height. Really unlikely. I don't know if I've ever seen a question like this where you have to use half AB sine C or anything like that. I can't see how that could work. Okay, so let's draw this ever so roughly to scale. So A is 0 minus 2. So that's going to be on the axes there. C is 0, 8. And D is 4, 4. Yeah, so that's now I've got that sketch. That's looking really quite nice. So, and this was the triangle they want the area of. So if I take that as the base, and that, so if I look at it in that orientation, that's all quite straightforward. So the base is basically just going to be the difference between minus 2 and 8. So the base is 10. The height is just going to be, highlighted. The height is just going to be, so obviously that's the y-axis is where x is 0. So the distance from there to there is just going to be the x coordinate. So the height is 4. So the area of that triangle, so just using half times base times height, is going to be a half of 40, so 20 square units. Okay, so yeah, so it's hard, until you've got a sketch, it's hard to see exactly how you're going to get the dimensions you need, but it usually works out pretty nicely, she says. Let's make sure those answers are correct. Yeah, so area of 10